In section 4.3, we're going to discuss greatest common divisors and least common multiples. The greatest common factor or greatest common divisor, we kind of use those words interchangeably, is the largest number that is a factor of each of the numbers. So let A and B be whole numbers, but not 0. The greatest natural number D that divides both A and B is called their greatest common divisor, GCD, and we write it as a GCD of A and B. You can write it also as GCF. I really don't care either way. If you want to say factor or divisor, they're both. We're going to look at 3 different methods for finding the GCF. The first method we're going to look at is the set intersection method. You list all the factors of each number as a set, and then you intersect the set of factors, and then you circle the greatest common factor. Now, when you're writing this on a test, I expect to see all of these steps, so really pay attention to how it should be written and what I would be expecting to see, because I'm more interested in the method than I am the answer here. So let's look at the greatest common divisor of 12 and 18 using the set intersection method. Since I've used D here, I'm going to write down the divisors of 12. I'm going to write them as a set, so I use my little squiggly brackets to represent a set. And 1 will divide 12, so will 12. 2 will divide 12, so will 6. 3 will divide 12, and so will 4. So that's all of the divisors of 12. And then I'm going to list all my divisors of 18. 1, of course, in 18. 2 and 9. 3 and 6. And I believe that's all. 4 or 5 does not divide 18, so that's all our divisors of 18. Now that I've listed all of them, I'm going to intersect the two sets. I'm going to find out where they, what they have in common, where they intersect. So the divisors of the 12 intersect with the divisors of 18. When I do that, the ones that I have in common are 1 and 2 and 3 and 6. Those are my common divisors. My greatest of those common divisors is the largest one, 6. That's hence the name greatest common divisor. It's the largest of all the divisors or all the factors of 12 and 18, the ones they have in common. So I'm going to write down the greatest common divisor of 12 and 18 equals 6. So be sure to note that on a test, that's what I would expect to see. I need to see the divisors of each number listed out, the intersection of those two sets, and then the largest of them. Now this method would work if you had 3 numbers or whatever number of numbers you do have. So that's the set intersection method. Let's look next at the prime factorization method. To do the prime factorization method, we're going to list each of the numbers as factors of its prime factorization. So we're going to express the numbers in prime factorization form. We're going to find the largest prime factor raised to a power they have in common. Let's look at this example. I've got the greatest common divisor of 18, 36, and 54. We're going to use the prime factorization method. So I'm going to factor 18. Let's do a factor tree for that. That's 2 times 9, and 9 is 3 times 3. So 18 is 2 times 3 squared. And then I'm going to factor 36. It is 4 times 9, and 4 is 2 times 2, and 9 is 3 times 3. So 36 is 2 squared times 3 squared. And then 54, let's use the short stack method for that. I'm going to short division. I'm going to do 2 will go into 54 27 times, and then 3 will go into 27 9 times, and then 3 will go into 9 3 times. So I end up with 2 times 3 cubed. So 54 equals to 2 times 3 cubed. And that is its prime factorization. once I have the prime factorization of each of those, I'm going to look for what they have in common. It's the greatest common factor. So notice that each of them have a factor of 2. And the largest exponent of 2 that's common to all of them is just to the first power. So my greatest common divisor of 18, 36, and 54 is going to be equal to 2 times. They all have a factor of 3 in common, and 3 squared, in fact, is the largest factor they have in common. So I will put down 3 squared. Now, if 3 wasn't in one of the numbers, then it wouldn't be in the greatest common divisor. The factor has to be in every single one. It's common to all of them. So my greatest common divisor of 18, 36, and 54 in this case is just actually 18. Okay. And that's how you can build it up. That's the prime factorization method. Let's do another example. This one, you're already given the prime factorization. We're going to find the GCF of two numbers a and b, where a is 2 squared, 3 to the 5th, 5 to the 6th times 7, and b is 2 cubed times 3 to the 7th times 5. So the greatest common factor of these two numbers, a and b, you can multiply it out to see what they are, but we'll just leave it like that. 2 is in each of them, and it appears at most 2 times in each of them. 3 is a factor in each of them, and it appears the smaller of the two numbers is 5, so that's the greatest one that appears in both. And then the factor of 5 is in each of them, and just 5 to the first power. The factor of 7 is only in a, so it does not appear in the greatest common factor or the greatest common divisor. You just leave it off. So these have to be common to both. They can't just be in one. So the greatest common factor or the greatest common divisor of those two numbers is this guy. And you can leave it like that or multiply it out. Let's look at the next algorithm. Third way to find the greatest common divisor. It's called the Euclidean algorithm. This is the theorem we're going to use. It said let a and b be any two natural numbers where a is bigger than b, and a is equal to b times q plus r. So basically you're going to divide a by b. And then you're going to find the quotient and the remainder. And then you're going to pair the smaller number, b, with the remainder. Because the greatest common divisor of a and b is equal to the greatest common divisor of b and r. So we're going to use that division algorithm to find the greatest common divisor of 7,286 and 1,684. So I'm going to skip down here so we have plenty of room to do that. That's going to be equal to the greatest common divisor of the smaller of the two numbers, 1,684, paired with the remainder. And what we're going to do is find out what the remainder is. And that's how we're going to figure out what the greatest common divisor is. So I'm going to take 1,684 and I'm going to divide it into 7,286. It'll go in there one time. It'll go in there more than one time. It'll go in there 4 times. And so 4 times 1,684 is 6,736. And I am going to subtract that from 7,286. And I've got 550. That's my remainder. And that's what I pair with the smaller of the two numbers. Here's my a, here's my b, there's my r. So now I'm going to pair it with b and r. which is also my new A and B. So I'm going to pair it with 550. Now, I'm just going to keep doing this until I can end this. So 550 now will divide into 1684. And it'll go in there 3 times. And that's 1650, and so I have a remainder of 34. That's my new remainder. Now, this is my new A and my new B, and this is my new R. Okay. So that's going to be equal to the greatest common divisor of the smaller of the two numbers, which is 550, and the remainder, which is 34. And so 34 will go into 550. It'll go into 55 one time. And that leaves me with 21, 210. We'll go into 210 6 times. That's going to leave me with 204, the remainder of 6. So again, this was my B, this was my R, now this is my A, and this is my B, and this is my R. So now I'm going to pair it with a smaller number in the remainder. Greatest common divisor, smaller number, which is 34, and my remainder, which is 6. And now I'm going to divide 6 into 34. 6 go into 34 5 times with a remainder of 4. And so I'm going to pair that together. Greatest common divisor of 6 and my remainder, which is 4. Now, at that point, you know the greatest common divisor of 6 and 4 is 2. But you can keep going. So I'm going to go ahead and keep going with this. I'm going to divide 4 into 6. 4 will go into 6 one time with a remainder of 2. So I now have the greatest common divisor of 4 and 2. And there's my remainder. So now I'm going to divide 4 by 2. And of course, 4 divided by 2 is 2. But the remainder is 0. So I'm now going to pair with the smaller number, the greatest common divisor, which is 2, with 0. Once you get to a number in 0, the greatest common divisor of 2 and 0 is just 2. It's the largest number that will divide them both. 2 does divide 0, since 2 times 0 is 0. So, anyway, the greatest common divisor, in fact, it's something you probably should write down and know. The greatest common divisor of any number paired with 0 is that number A. So you can keep going and going and going. Really here at this point you probably knew, even at this point you probably knew that it was 2. But you can continue on down until you get that remainder to be 0. That is called the Euclidean algorithm. And it works for very large numbers that would be otherwise difficult to find the prime factorization of and very difficult to list all the factors of. So it gives you a kind of a shortcut way to do that. Now, 2 whole numbers, A and B, are relatively prime if and only if the greatest common factor of A and B is 1. So if you end up with, when you finish, if you find the greatest common divisor of those 2 numbers, A and B, is 1, it's the only common factor they have, then we say they're relatively prime. So I'm going to give you the answer to the last question on your little quiz. That's not material related. The question is, what is my least favorite food? My least favorite food that I still refuse to eat even to this day is sauerkraut. There you have it, folks. Hope you all have a nice spring break. Make sure you watch all 3 videos, get the questions answered, and be prepared for class on Monday. The homework assignment from section 4.1 is going to be due on the Wednesday after spring break. Give you a little bit to make sure you get caught up.